speaker will be Professor Elnimeiri from IIT. Professor Elnimeiri earned his doctoral degree from Northwestern University, Evanston, Illinois. He has been involved in the practice of structural and architectural work of buildings in Chicago. He is very active and well known in the professional and academic communities. He is currently a member of steering committee of CTBUH. He'll talk on Dwight Tower 29, structure and form. Please welcome him.
Good morning. I guess it's good afternoon now. I'm not sure, but good morning, I guess. I would like to talk about, I guess, the structure and form. This is a general talk, and in reference to Tower 29, Dubai Tower 29. Like most kind of projects like this, you have to acknowledge a lot of people. It would never happen without a lot of active people involved. First of all, I would like to acknowledge the architect, TVS, based in Atlanta, Georgia, and Chicago. And also they're supposed to be here, but I guess they couldn't make it. For some reason, they missed the flight or so. In any case, I also want to acknowledge Arab engineers who will be the engineers of record to build this building. Our involvement is really in the concept of Tower 29, the tallest tower of the group. But last night, I've been thinking a little bit, so I want to make a connection between structure and form. So I decided to put some slides to go back and thought a little bit about this. And there are only a few slides. I don't think hopefully they will not impact the time. Okay. So what I wanted to talk about structure and form in the era, what I call the modern era. The era where architecture and structure are almost synonymous. They were the two faces of the same coin in a way. Eiffel Tower, I don't know, every time I make a presentation, I show Eiffel Tower as a symbol of a tall building, but well structured. It has all the magic proportions of what we call an honest structure. Of this modern era, I'm looking at some of these tall buildings, and I'm just going to focus on the buildings in the Chicago. The tallest, of course, is the Sears Tower. This presentation is not, I don't want to make any judgment on the architecture in any sense, or on the sustainable items of the structure, of the architecture. I really just want to make the connection between architecture and architectural form and structure. At that time, it became apparent that the structure and the architecture, they were connected. Structural engineers, they start developing something called the structural systems. Structural system is a system that is important, very important, to be able to build a building. Structural system is very important, is to try to define the economics of the structure. The structural system is important, obviously, to guarantee the integrity of the structure standing up. These systems, I published this kind of chart about 10 years ago. I think if Mirali is here, he published a book on architecture of tall buildings. I published this work there. This is about steel structures. I don't want to dwell on it, I don't have time. This is about concrete structures, what the systems are. But I wanted to talk about Sears Tower for a couple of minutes as a testament of what I call a compatible architectural structure idea. In fact, I listened many times to the architect who designed the building and to the engineer who designed the building, and every one of them claimed that he designed the building, and probably most of them are right. Because in so many ways, I'm talking about the structure. We look at the plan at the base. It is really what they call modular system architecturally, and structurally what you call a bundle tube structure. Bundle tube, there are 9 tubes at the base, and then of course the tube drops off as you go up in the top of the building. Structurally, this is wonderful because the whole idea of bundling is to add stiffness to the system. Architecturally, that is wonderful because you don't need higher space when you go up in the building. This is the structural idea of the stiffness, essentially to mitigate what they call shear lag. In other words, if you have a very thin tube, it will be subjected to very serious lag, and this is one way of mitigating it. This is a structural system. It's very simple, very straightforward, and manageable. At that time also, there was an important concern about structure can only be, structure is a structure if it is realized. Actually, only if it is realized, only if it is buildable. So, structure was driven from construction. So now we're saying architecture is driven from structure, and structure is driven from construction. And in other words, the structural system is embedded in this idea, how are you going to build the building? You have to address that question. And in fact, the tube structure of Sears Tower, this is as built, the slide you see here. And this is the reason the way it was done that way, because of how do you bring the, transport the elements to the site. And this is a slide of Sears Tower during construction. And it's a wonderful slide because this is probably the time that Chicago was like maybe Dubai as now. This is the booming time of Chicago, and when it was up there. Most of the tall buildings in Chicago were built at this time. This is another shot from the top of the building at night. This is another building, Onterie Center. In fact, this is a building that I did in SOM when I joined SOM in 1982. This is exposed concrete structure. There is no cladding, and this is a concrete building. Of course, when you look at the bracing, you assume, wow, this maybe is a steel building. It is a concrete building. It's an exposed concrete building. In fact, it's the first concrete braced structure in the world. So, conclusion of these sets of slides is twofold. Number one, there is a complete interaction or the complete integration between architecture and structure. In fact, at one time, a very well-known architect by the name Myron Goldsmith, he termed this type of architecture as what he called it structural architecture. In other words, it is architecture is the expression of the structural system. This is what I call the architectural form of today. I'm jumping maybe 20 years between what is happening in Sears Tower, what is happening today. And I'm just going to go over these slides without making any comment at the time. Some of these buildings are built, some of these buildings are under construction, some of these buildings are under design, some of the buildings are in research phases. But they're all developed from real programs, and like I said, some of them are built. This is Calatrava Tower in Chicago, Spire. I will talk a little bit about that for a second. this is, I didn't know that, but I just realized that somebody just told me a few weeks ago that the project is going ahead, this one, the one in Saudi Arabia. It looks like a cobra. Again, I'm not talking about sustainability, or I'm not talking about any comments about the architecture. I'm trying to make the point here about what really happened to architectural form in the last 30 years, and how that form, what is then the relationship between structure and form in this time, and how the structure engineer would react to this kind of architectural form. So, I will, one more. The Calatrava form. We did a lot of study. I'm also a practicing engineer and chairing a consulting firm by the name CDCI in Chicago. It's an international firm, and we do a lot of work in this area. However, this study we did in our class in the school, and to look at the spire and to see how, again, mitigate the structure of this form. And this is as in plan. By the way, the building now is under construction. They broke ground a few months ago, and it's going very fast. This is from Santiago Calatrava. I personally know him, and he's a very creative guy. And this is an inspiration of his approach to design, essentially from nature. This is his hand sketches on his idea of the form. I wanted to go back to the structure. So where is the structure? The structure here has no relation to the form. The structure is the shear wall in the middle. And although when you look at the architecture from outside, it is twisting. It is a twisting tower, 360 degrees. But the structure is not twisting. The structure is not moving. Even the slabs are not moving. The slabs are worked out in a certain way to give that impression. In other words, the structure is not integrated completely into this architectural form. This is just one thing I wanted to mention here, and I'm going to skip this. Okay, I'll walk you through the building. This is the lagoon structure. Tower 29 is the tallest one, is 550 meters tall. You can see it in the background here in the back. This is rendering of the form. This also Werner Sobek is working with us on the exterior of the building. So this is the spire. It's called the crown in this one. There are atriums, again, to mitigate certain issues of light. Elevator system. Again, I don't have the time to dwell on it. I have to talk, if I can take just 2 more minutes, about the structure. So, how do we look at this structure? My research and my way of thinking that I have to find a way to integrate the architectural form or to integrate the structure within the architectural form. In other words, to take advantage of this form, to see how useful that form into helping us to help the structural system. There are a lot of issues, and unfortunately I don't have the time. It is in the publication, it is in the proceedings, but this is something I did for the first time, I never really did before, is to build a physical model, an architectural model to the left and a structural model to the right. And why I'm building the model? I'm building a model, first of all, to see if this building will stand up, just to look at it. And what is the balance? To use this geometry so that we can balance things out. I guess my time is, I'm running out of time. I was going to talk about the form, how we generated it mathematically, and how we created in the form, integrated it. We wrote programs to integrate the structure with the form. What we call parametric study of this form, and to see how at the end we tune the structure in such a way, of course, to satisfy all the requirements of the structure, the stability, the stiffness, the dynamic response of the building, and so on and so forth. I'm very sorry I can't continue anymore. So thank you very much.